Welcome back to our series. In this video, we will cover the next few problems from chapter 4 of NCERT 11th standard, Motion in a Plane. So let us see question 4.15. The ceiling of a long hall is 25 meters high. So the ceiling is 25 meters high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling? So without hitting the ceiling, we have to find how long the ball will go. Now, if the ball is not hitting the ceiling, then to find the maximum horizontal distance, we will take the case where the ball is just grazing the ceiling. It is not hitting the ceiling, but it is just going under the ceiling. That is the maximum height, or the height reached by the projectile is 25 meters. Height reached by the projectile is 25 meters. U given is 40 meter per second, and we have to find range of the projectile. Range of the projectile we have to find. Okay. Now we know height reached by the projectile, max height reached by a projectile is given by u square sine square theta by 2g, u square sine square theta by 2g, where theta is the angle of projectile and g is 9.8 meter per second square, acceleration due to gravity. Therefore, substituting the values, we want maximum height reached by the projectile to be 25 meter. So 25, u is 40, so u square is 1600 sine square theta divided by 9.8 into 2 is 19.6. Therefore, we will get sine square theta is 25 into 19.6 divided by 1600, which will come out to be 0.30625. Therefore, this would make sine theta to be equal to 0.5534. That would make theta is equal to sine inverse of 0.5534, which is approximately 33.6 degrees. 33.6 degrees. Okay, this is angle theta. Now, what is range of a projectile? Range of a projectile R is given by u square sine 2 theta divided by g. U square sine 2 theta divided by g. So it will be u square sine of 33.6 multiplied by 2 will be 67.2 divided by g. So this will be 1600 upon 9.8 multiplied by 67.2 degrees. Its sine is 0.9219, and this comes out to be 150.5 meter. This comes out to be 150.5 meter. So, to find the maximum distance reached without hitting the ceiling, what we will do? The limiting case would be the projectile thrown, the ball thrown just grazes the ceiling. It is not hitting the ceiling, but it is just going past the ceiling. Okay. Therefore, that will give us the maximum horizontal distance, which comes out to be 150.5 meter. Let us move to the next question. A cricketer can throw a ball to a maximum horizontal distance of 100 meters. So R range, R max is 100 meters. We have to find H max. Now all of us know maximum range is always at 45 degrees. So R max is equal to u square by g, because if theta is 45 degrees, twice of theta will be 90 and sine of 90 is 1. So R max is u square by g, which is given to be 100 meters. Therefore u square is 9.8 into 100, which is 980 meter square per second square. So u square is 980 meter square per second square. That is u square. Now what will be the maximum height reached? Now maximum height will be reached if the ball is thrown straight vertically upwards. If the ball is thrown vertically upwards, that will lead to it reaching maximum possible height. So there H max will be u square upon 2g. U square upon 2g, because there theta will be 90 degree, so sine theta will be 1, and therefore sine square theta would be 1. So this would make 980 upon 2 into 9.8. This would make it 50 meter. This would make it 50 meter. Question 4.17. A stone tied to an end of a string 80 centimeter long. So R is 80 centimeter, which is 0.8 meter, is whirled in a horizontal circle with constant speed. So speed V is constant. If the stone makes 14 revolutions in 25 seconds. So what? Let us find the speed first. Speed V would be total distance traveled would be 14 multiplied by distance in one revolution, 2 pi r. 2 pi r divided by time is 25 seconds. So this would be 14 into 2 into 22 upon 7. R is 0.8 and divided by 25. This would be 88 upon 25 into 0.8. So let us keep it as it is for now. So this would be velocity v. We have to find the magnitude and direction of acceleration of the stone. Now we always know acceleration of the stone will be towards the center of the circle. Acceleration will always be towards the center. If the stone was here, acceleration would be towards the center. If the stone was here, acceleration would be towards the center. And its magnitude is acceleration, centripetal acceleration is v square upon r. V square upon r. So this will be 88 upon 25 multiplied by 88 upon 25 multiplied by 0.8 into 0.8 upon r is 0.8. So this would be 88 upon 25 multiplied by 88 upon 25 multiplied by 0.8. So 25 3s are 75. 13 means 25 5s are 125, 15 means 25 2s are. So 88 by 25 is 3.52 multiplied by 3.52 multiplied by 0.8. So this would become 12.39 multiplied by 0.8. It will be 8 9 is 72. 7 8 3s are 24 plus 7 31. 8 2s are 16 plus 3 19. So magnitude of acceleration would be around 9.912 meter per second square, and the direction will always be towards the center of the horizontal circle. Towards the center of the horizontal circle. Let us move to the next question. Question 4.18. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 km per hour. Compare its centripetal acceleration with acceleration due to gravity. So we know its speed is 900 kilometer per hour. Because we want to compare acceleration with acceleration due to gravity, let us convert the whole thing into meter per second. So this would be 900 into 5 divided by 18. So 18 ones are 18 fives are. So it is 250 meter per second, and radius r is 1 kilometer, which is 1000 meter. Therefore, centripetal acceleration AC is v square divided by r. So it is 250 multiplied by 250 divided by 1000. So it is 62.5 meter per second square, and it will always be towards the center. And we know acceleration due to gravity is 9.8 meter per second square. 9.8 meter per second square. Therefore, let us find by how many times is centripetal acceleration greater than gravitational acceleration. Therefore, AC upon G would be 62.5 divided by 9.8. So this comes out to be around 6.4 G. So this is around 6.4 G. So this will be around 6.4 G. Let us move to the next question. Question 4.20. Position of a particle is given by r equal to 3.0 t I cap minus 2.0 t square j cap plus 4.0 k cap meters, where t is seconds and coefficients are proper units, and r is in meters. We have to find velocity vector and acceleration vector, and we have to find magnitude and direction of velocity of the particle at time t equal to 2 seconds. So velocity vector is d by dt of position vector. So it will be d by dt. Position vector is 3.0 t I cap minus 2.0 t square j cap plus 4.0 k cap. So this would become 3.0 I cap minus 4.0 t j cap. So velocity vector would be 3.0 I cap 4.0 t j cap. And we know acceleration vector is d by dt of velocity vector. So this would be d by dt of 3.0 I cap minus 4.0 t j cap, which would be minus 4.0 j cap. So this would be acceleration vector. Therefore, this is the velocity vector, this is the acceleration vector. Now we have to find magnitude and direction of velocity at t equal to 0. So v at t equal to 2.0 seconds would be 3.0 I cap minus 4 to the 8. So 8 j cap minus 8 j cap. So it would be in the xy plane along this vector, and its magnitude of v would be under square root 3 square is 9 plus 8 square is 64. So this is under square root 73 meter per second. So this will be magnitude of velocity vector at time t equal to 2.0 seconds. Let us move to the final question that we will cover in this video, which is 4.21. A particle starts from origin at t equal to 0 seconds with velocity of 10.0 j cap meter per second. So its initial velocity is only in the y direction and moves in the xy plane with constant acceleration of 8.0 I cap plus 2.0 j cap meter per second square. So acceleration is both in x direction and y direction. At what time is the coordinate of the particle x coordinate 16 meter, and what is the y coordinate at that time, and we have to find speed of the particle at that time. So we will divide the motion into x direction and y direction. So x direction, and we have y direction, x direction and y direction. So ux will be 0 because initial velocity in the x direction is 0. Ax is 8 meter per second square. Sx, which will be the displacement, is 16 meter. So we will use second equation of motion. From that we will get t square is equal to 2s by a. So it will be 4. Therefore time will be 2 seconds. So time will be 2 seconds. Therefore at 2 seconds we have to find sy. We have to find sy. So again we will use second equation of motion. Sy is equal to uyt plus half ay t square. So uy is given to be 10. 10 into 2, 20 plus half into ay is 2 into 4. So this is 24 meter. So displacement or the y coordinate of the particle at that time, at time 2 seconds, is 24 meter. We have to find speed of the particle at this particular time. We will find x component of the speed, y component of the speed, and then calculate its magnitude. So Vx will be 0 plus 80. So this will be 16 meter per second, and Vy will be u is 10 plus acceleration is 2, time is 2. So this will be 14 meter per second. Therefore magnitude of velocity will be under square root 16 square plus 14 square. So this would be under square root 256 plus 196, which is equal to under square root 452, which is approximately 21.26 meter per second, which is approximately 21.26 meter per second. So this is the speed of the particle at 2 seconds, and this would be the y coordinate at 2 seconds, and time 2 seconds was calculated when the x coordinate was 16. Hope you like this video. In the next video we will look at some more problems, including the additional exercise of the 4th chapter. Thank you.